Tetrahydrocannabinol, better known by its more common name THC, is the chemical component of marijuana that is responsible for the psychological effects on the human brain. Along with THC, there are around 60 other cannabinoids found in marijuana that can all produce specific reactions within the human body and temporarily alter the mental status of individuals who use or smoke marijuana. THC specifically reacts with cannabinoid receptors in the brain that are responsible for thinking, memory, pleasure, and coordination, and activates them to affect an individual's perception. THC is an organic molecule with a formula of C21H30O2 with a 3-cyclic ring structure that includes one benzene ring, an alcohol group, and an ether with a long hydrocarbon tail. Within its structure are 2 stereocenters that, according to the stereoisomer 2 to the n rule, produce a total of 4 possible stereoisomers. These 4 predominant stereoisomers are positive trans delta 8 THC, trans delta 8 THC, positive trans delta 9 THC, and negative trans delta 9 THC. Each of these isomeric forms exhibits slightly different chemical properties and all exist differently in natural and synthetic settings. For instance, the plant marijuana mainly has the stereoisomer negative trans delta 9 THC, while many synthetic pathways that make THC products in laboratories produce the trans delta 8 THC isomer because it is more stable. The full systematic IUPAC name for the stereoisomer of THC naturally occurring in marijuana plants is negative 6AR 10AR 669 trimethyl 3-pentyl 6A78 10A tetrahydro 6H benzo C chromin 1-ol. As previously mentioned, there are many functional groups within the THC molecule that aid in determining the structure's properties. For instance, the length of the hydrocarbon side chain directly correlates with bonding affinity. The longer the chain, the higher binding affinity at the molecule's receptors. Similarly, when THC was first synthesized, it underwent many modifications in order to help figure the structure-activity relationship of THC at both the CB1 and CB2 receptors in the brain. It also underwent experimentation in order to substitute the aliphatic region on the molecule as well as modifications to the saturated alkyl chain in an attempt to change the molecule's properties. THC's chemical structure is similar to the neurotransmitter anandamide. Anandamide is considered an endocannabinoid and binds to the THC receptors in the human brain, creating feelings of euphoria such as joy and bliss. Since THC's structure is similar to anandamide, the human brain can mistake it as anandamide and allow THC to bind to THC receptors in the brain, which in turn alters normal brain communication, creating effects such as alteration of the hippocampus and creating impaired thinking. The effect THC can have on a human being's brain is why THC is a very important issue in today's culture and in the legalization of the product. For instance, THC attaches to cannabinoid receptors on neurons and activates them, which can disrupt various mental and physical functions such as the cerebellum and basal ganglia, parts of the brain that regulate bodily functions such as balance, coordination, and reaction time. Also, THC can act through cannabinoid receptors to activate the reward system of the brain and stimulate the effects of pleasurable behaviors, such as eating and sexual intercourse. Overall, THC is a naturally occurring chemical component of the plant marijuana that can have physiological effects on the human brain. It can also be synthesized and has 4 naturally occurring stereoisomers, the most common being negative trans delta 9 THC, which is in plants, and trans delta 8 THC, which is mainly being produced in laboratories. THC continues to be a hot topic, whether it be scientifically, pharmaceutically, or recreationally, and the drug has much more to be uncovered about its chemical properties and effects.